Hello, and welcome back to Political Science 4781, Techniques of Political Analysis. We are talking about what not to do today, that is, examples of bad data visualizations. In the previous video, we talked about the first part of a gallery of visualization badness, and today I want to talk about the second part of the gallery, continuing along the same lines, because they're more examples than could fit into a single video. So here's a stacked bar graph showing you opinion about same-sex marriage. And if you look at this bar graph, you might ask yourself, who cares? Right? Opinion seems to be pretty static over time. It doesn't really seem to be doing very much. So this conveys a story, intentionally or unintentionally, that there's really not a very big change in public opinion about whether or not gays and lesbians should be allowed to marry legally over the course of 12 years. Now, if we take another look at exactly the same data in a different format, you get a totally different picture. As my mother told me when I showed her the first article that I ever published, crossing lines is good. It tells you that one thing has surpassed another. Now, we're probably not, at this point when this graph was made, the difference between the two opinions expressed was probably smaller than the margin of error between the two of them. But still, it's a very different story. And this is a good example of a theme that we're going to come back to, obviously, because this is a class about data and politics. The problem of, or the issue of graphics that convey a particular message, and a particular partisan message. And the reason that you don't want to do that for a couple of reasons. First of all, because it's disingenuous. You, as a data analyst, it's your job to see as much as you can of all sides of the story. And for another, it's ineffective. The moment you pass along a data visualization that clearly has a particular partisan slant, you're going to turn off a significant percentage of your audience. So these two graphs are very different ways of looking at the same numbers. And you have to ask yourself, which is the clearest, which is the most objective. It isn't this one. This is views on the legalization of same-sex marriage by religious affiliation, and you can take a quick look at it and get a sense that Jews are much more in favor of same-sex marriage than evangelicals and Mormons, but boy, is that a really unnecessary, unpleasant thing to try to force people to look at. The blobs, it's sort of difficult to tell exactly where the peak is. We don't know why they're sort of tailing off like a normal distribution on either side. It's added design elements for no particular reason. Speaking of which, this is one of my favorite more recent graphs. The production outlook for the Barnett Shale from 1995 through 2030, or as I call it, the sand dune graph. I have no idea what these lines, what these stripes represent. I have to think they don't represent anything really, because the colors repeat, and you couldn't possibly have a legend on this thing that would make any sense as far as I'm able to tell. So my best guess is that the peak of this curve is the story that they're trying to tell, and the lines are just there because they look pretty. But the problem is that lines like that are very, very common design elements, except they don't start sort of at the curve and then taper down to the right-hand margin. So this is, I don't know. I love it because of how baffling it is. If any of you have any guesses as to what the colors are doing, please don't hesitate to let me know, because I sure have no idea. Now, this is what's called a stacked horizon graph, and it's used once in a while. You'll see it. Basically, the idea is that the darker colors represent higher numbers, and if these little tiny strips were allowed to go higher vertically, then the darker segments, the darker areas, would be stacked on top of the lighter areas. It's sort of a compact way of representing more change than your regular graph would allow you to in a very thin area. But at the same time, it's got a couple of frustrating features. The information that it portrays is pretty redundant in some ways, in that if you see the darker area, the darkest area, then the colors of the areas behind it become somewhat redundant at that point. More to the point, the scales are really difficult to figure out. That is, is how much taller is the medium red area than the pink area. You can probably try to get a sense of that, but it's not immediately obvious from this. The other thing is this particular graph disaggregates the data by state, which is not necessarily a problem. It lists the states in no particular order as far as I can tell, except that ones with more unemployment problems are higher up. But it differences the data. That is, it looks at the difference from the national average. And that inherently masks overall trends, nationwide trends. That is, whatever the average is at a given point in time is a neutral point between light blue and light pink. And if the overall unemployment rate changes, but the state's unemployment rate doesn't, you'll get an artificial change in the state. It doesn't give you any sense of the overall trends. It's so disaggregated that it becomes difficult to figure out what's going on. Maybe a better perspective, although it doesn't break it down by state, is this graph, which shows you every month of every year what the jobless rate was. And if you're looking to compare by states or regions, it's pretty straightforward to show maps, and that has the advantage that you can see particular areas within states that are problematic. You can see whole regions that have more unemployment than other regions. Granted, you have to show more maps, but it's not that big a problem given the number of years that we're looking at. Okay, so if what you're trying to do is disaggregate unemployment trends over time, really I think the most effective way to do it is with a series of maps, heat maps like this one. Now, this graph is telling us something interesting. That is that average test scores are better for people with TVs in their bedrooms and worse for people without home computers. Which tests, I'm not entirely sure, because it doesn't tell us. How significant the differences are, how meaningful the scores are, I don't really get a sense from this. Mostly, though, there's all this crap in the background that really distracts you from even understanding the central message. And this is what Edward Tufte calls chart junk. That is, ink that doesn't convey information in a graph. And this is an important principle to keep in mind when you're drawing a graph. You should always ask yourself, if I'm creating some kind of ink in this graph, digital ink or actual ink, what purpose is it serving? Is it actually conveying information, or is it just being decorative? In this case, you've got this sort of three-dimensional bar chart that isn't telling you anything more than a two-dimensional bar chart would, as a matter of fact, because it's not entirely clear how far it's not immediately visually obvious how far the bars are away from the background. there's a little bit of slippage between the back line and the tops of the bars. So in general, simpler is better. It's an important principle to keep in mind. Now this bar chart gets it in terms of the design elements, right? It's got simple bars, there's no frippy stuff in the background, there's not a lot of extra ink. The weird thing here is the percentages. So this is showing us digital marketing budgets and revenues, a percentage of respondents who are telling us something, and some percentage, presumably something like how much the budget should be, or something. But it doesn't tell us, and then you have a breakdown of percent of marketing budget spent on digital and percent of revenues derived from digital within each of these percentage categories. So what the percentages of percentages are, I have no idea. The most baffling part is the average over on the right, 35 and 34%, which is a bigger number than any of the individual bars for any of the other categories. This, again, if you stare at it and get some sense of what exactly it's talking about, go ahead and let me know, because it's pure speculation on my part. This is from The Economist, which generally knows better. This is a case in which you're comparing 8 quantities. Sorry, I missed the little human organs down there. And you're taking sort of existing conventions for how to convey proportions or parts of a whole, and just throwing them completely out the window and saying, let's create this bubbly thing, and people will immediately understand that that bigger is a larger percentage or a larger fraction. It takes a little while to figure it out. More to the point, in the same way that we're not very good at gauging how big a wedge of a circle is, we're pretty terrible at gauging the area of a circle. And so this isn't really as intuitive a representation as it seems at first. This one, however, pales in comparison to this thing. This compares the performances of a handful of hedge funds in 2007, and the size of the circle represents sort of how well or poorly they did, and their placement on the side of the losses and gains column tells us whether they were in the red or in the black. Now, the odd thing is that, one of the odd things, first of all, why is one of them yellow and the others are, I have no idea. Second, when you have sort of losses on one side and gains on one side, you intuitively expect there to be a scale. That is, the farther you get from the zero line, the bigger the losses and the gains are going to be. But that's not the case here. Distance from the zero line has absolutely nothing to do with plus. Harbinger Capital Partners at plus 118 is closer to the zero line than Bridgewater Pure Alpha is at plus 9.5%. Now, if we want to compare that to their performance in 2011, boy, how does this help you? What does this do? Do you get a sense of who did well and who did poorly, and in which years? Probably you've forgotten which of the big bubbles were black last time, except for Paulson, which is still yellow. You don't really get a sense of how they've performed relative to one another. This is, if what you're trying to do is publish the data while hiding it in plain sight, this is actually a pretty good way of doing it. A considerably better way of actually showing the data would be just to graph the performance of the investment firms in 2007 and 2011, and show which ones improved in terms of performance and which ones went down. Now this even has a fair amount of ink in the middle that is a little bit, technically speaking, incorrect, because these the returns of these companies didn't sort of dive on a steady line from one place to another, or slowly rise on a steady line from one place to another. They changed between 2011. So an even better representation would be this one, which just shows, the clear dots are 2007, the filled-in dots are 2011, and you can see, if the filled-in dot is to the right of the clear dot, they did better in 2011. If it's to the left, they did worse. If there's a big gap, there's a big change. It takes a moment to read this this is a Cleveland style dot chart, and we'll be learning how to make those later on in the semester. Okay, so that is it for the gallery of data visualization badness. If you want more examples, there's a blog that's devoted exactly to examples like this, and I've stolen a few of the examples here from it. It's called Junk Charts. It's at junkcharts.typepad.com, and it's run by a statistician with the wonderful name Kaiser Fung. So I highly recommend checking it out as a way of sharpening your data acuity.